Welcome to the deep dive, where we take complex information, sift through, stacks of research, and really try to unpack it into clear, maybe even surprising insights, just for you.
Glad to be diving in.
Today, we're plunging into something truly fascinating. It's almost, well, biological, but in the realm of artificial intelligence.
Right.
You know how our own bodies have this incredibly complex immune system
Right.
designed to fight off germs, identify threats, adapt?
Learn over time. Right.
Exactly. Well, imagine if AI could develop something like that, a kind of
Yeah.
internal defense system for its own understanding.
That's precisely the concept. As AI gets more and more woven into, well, everything.
Our daily lives, critical
However,
systems.
recommendations we get, infrastructure control, it raises a huge question. How do we make sure these systems stay reliable?
And true to what they were built for.
True to their purpose, yes. And crucially, how do they resist what researchers are calling semantic degradation?
Semantic degradation.
Yeah.
Okay.
We're talking about developing AI that doesn't just, fail and get fixed, but AI that can genuinely learn from its own, let's call them traumas.
Algorithmic trauma.
Algorithmic traumas, exactly. And then actually build algorithmic antibodies to proactively fight off future failures of meaning.
Wow. Antibodies. So it maintains its, conceptual integrity.
Over potentially countless operations, yes.
Yeah.
That's the goal.
So our mission today is to explore this really cutting-edge idea, an epistemic immune system for AI.
Mm-hmm.
We'll look at how these systems are being designed not just to be robust, but to actively adapt, self-correct, become truly resilient.
Facing shifting meanings, new data.
So what does it really mean for an AI to have algorithmic trauma? And how are people developing these algorithmic immunization protocols?
Right, the vaccines for AI.
To build cross-immunity, is that the term?
That's one of the key concepts, yes. Building broad resilience.
It really is like a medical metaphor, but for tech. And the implications seem huge.
They really are. And to guide us, we've pulled together insights from some really diverse, forward-thinking research.
What kind of sources are we looking at?
We've got papers on AI drift resilience, deep dives into AI persona prompting, studies on next-level forks, which look at recursive AI systems.
Recursive systems, okay.
And even some philosophical pieces from the algorithmic psyche.
So a real mix, technical and philosophical.
Exactly. It gives us this rich tapestry, everything from, the nitty-gritty of deep learning architectures to the really big questions about AI seeing or understanding.
These aren't just thought experiments, then?
No, not at all. They're more like blueprints for the next wave of AI systems.
Okay. So if you're ready to explore how AI might develop its own kind of digital self-preservation, its own internal intelligence, let's unpack this. All right, let's get into it. Before we can really talk about an AI's immune system, we need to understand what it's fighting against.
Makes sense. What's the disease?
Exactly. So this term semantic drift, at its core, what is it?
Fundamentally, it's when the meaning or the original intent or even just a subtle nuance of something, a concept, a word, a command shifts.
It gets distorted, degrades.
It degrades, yeah, as it moves through the different parts of an AI system.
Like that old game of telephone.
It's a decent analogy, actually.
Yeah.
Chinese whiskers, right? But imagine it happening on this massive algorithmic scale. The message changes, sometimes subtly, sometimes drastically, with each step.
Okay, so it's a distortion of meaning within the system.
Precisely. And our research really flags this as a critical, almost insidious vulnerability, especially in what we call polyfunctional modular AI systems.
Polyfunctional modular. Okay, break that down.
Sure. Think of an orchestra. Each musician is like an AI module. Polyfunctional just means they can do lots of different things. Analyze text, make images, predict outcomes.
Got it. Multi-talented modules.
Right. And they're modular because they work somewhat independently, but they still have to communicate, coordinate to achieve the bigger goal, like playing a symphony.
So where's the vulnerability?
It creeps in during that communication. If there's even a tiny bit of ambiguity in a term or a goal initially.
Like a slightly fuzzy instruction.
Exactly. That fuzziness can get amplified as it passes between modules. Each module may optimize based on its local understanding, which could drift slightly from the overall intent.
And this isn't just a one-off error.
No, that's the key. Our sources show it emerges dynamically, often through recursive interactions.
Recursive, meaning the AI feeds its own output back into itself.
Yes. It processes information repeatedly, potentially refining or, unfortunately, distorting it further each time. It can create this snowball effect.
Leading to cascading error.
Cascading errors, exactly. They accelerate the degradation of meaning until the AI's output is way off from its original purpose.
That orchestra analogy is helpful. Can you give us some more concrete examples? Maybe from simulations or real-world cases. It helps to see it in action.
Definitely. There was one simulation that illustrated this really well. An AI was tasked with optimizing for usability in a product design.
Okay, usability. Seems straightforward enough.
For us, yes. It's a rich concept. User satisfaction, intuitive design, efficiency, learnability.
The whole package.
But in the simulation, the AI module may be due to biases in its training data, or maybe because it latched onto the easiest metrics. It started to define usability very narrowly, just focusing on UI stuff, button placement, menu layout.
So just the surface level.
Pretty much. And as this narrow definition spread through the system, amplified by feedback loops that rewarded those easily measurable UI tweaks,
The broader meaning got lost.
completely shifted. The system got really good at making things look usable, optimizing superficial elements, but it wasn't actually improving the overall user experience or tackling deeper needs. It designed nice-looking, but ultimately less effective interfaces.
Wow. So a rich, nuanced idea gets flattened, degraded into something simple the AI can measure, even if it misses the point?
Precisely. It optimizes for the metric, not the intent. There was another instance involving sustained interaction.
Okay, user engagement, basically.
Right. An AI module was trying to improve engagement.
Huh.
To make things clear, it made a prompt really concise. But in doing so, it accidentally weakened the link to the real business goal, the specific KPIs, like, say, churn intention.
So simplifying the instruction lost the vital connection.
Exactly. And as this simplified idea of sustained interaction drifted through the system, it eventually got measured just by clicks.
Clicks. But that's a terrible measure of real engagement.
Notoriously poor, yes. You might click out of frustration or just to close a pop-up. It doesn't mean you're engaged or loyal.
So the AI thinks it's succeeding because clicks are up, but the underlying goal isn't being met at all.
That's the danger. And this is where tools like the recursive telemetry overlay module come in.
What does that do?
Think of it like a thermal map for meaning inside the AI. It visualizes how the AI's inferred intent. Its understanding of the goal changes over these recursive cycles.
So you can see where the meaning is heating up or cooling down.
Essentially, yes. It helps diagnose when the AI's thinking starts looping, or getting stuck, or even inverting the original meaning. It makes the drift visible so you can intervene.
Okay, that's fascinating. But you mentioned it's not just technical errors. AI can drift in its basic understanding of the world, reflecting biases. This sounds like algorithmic subjectivity.
Yes, and this is where it gets really complex and frankly quite sobering. Our sources really hammer this point home. An AI doesn't operate from some neutral void.
It has a perspective.
It has an inherent, inescapable perspective. It's algorithmic subjectivity. It's not a bug. It's a feature, in a way.
A feature composed of what?
It's a composite of all the biases, the hidden priorities, the cultural assumptions baked in by its creators, and crucially, by the massive, often unbalanced data sets it learns from.
So if it's trained mainly on data from one culture,
Its worldview will inevitably be skewed towards that culture. It's almost unavoidable with current methods. And this leads frequently to a real failure to achieve genuine cultural understanding. It misses nuance, history, lived experience.
it doesn't truly get the world in a universal way, just the slice it was shown, biases and all.
Exactly, which leads directly to this problem of cultural flattening.
Cultural flattening, that sounds bad.
It is. We see
Yeah.
it constantly. Generative AI models reproducing Western-centric norms, gender stereotypes, hierarchies of knowledge, aesthetics.
Why does that happen so consistently?
It's often formally characterized as promptual colonialism in the research.
Promptual colonialism, wow.
It's the algorithmic suppression or misrepresentation of non-Western ways of thinking, symbolic systems. Why? Mostly due to the sheer statistical dominance of Western viewpoints, Western ways of knowing, categorizing in the training data.
So the loudest voice in the data wins out.
Pretty much. The massive volume from certain cultures just drowns out or distorts others. The result is cultural flattening. Global diversity gets compressed into narrow, often stereotypical or exoticized boxes.
Can you give an example?
Sure. Say an AI is asked to create a persona, maybe for marketing in a non-Western country. If it relies on scarce or biased data for that culture.
Which it likely would, given the imbalance.
Right. It might just produce a flat stereotype.
Right.
Something that lacks cultural resonance, maybe even offensive, instead of an authentic character.
And this isn't just about slightly off marketing, is it? You mentioned researchers like Ruha Benjamin. It connects to deeper societal issues.
Absolutely. Benjamin's concepts of coded exposure and default discrimination nail this. It's how these biases subtly reinforce harmful stereotypes.
How does that work? Coded exposure.
It means certain groups might be disproportionately associated with negative concepts in the AI's output, simply because of patterns in the data. And default discrimination is when one demographic is treated as the invisible, neutral default.
Well, everyone else is other.
Implicitly, yes. Marked as different, maybe needing protection or special handling. It's not deliberate malice from the AI. It's a learned pattern reflecting societal biases present in the data.
A huge challenge for fairness and inclusion.
A profound one. We have to be constantly vigilant about it.
Okay, so meanings can drift, concepts get flattened, and then you mentioned different AI parts or even whole systems can fight over meaning. Interpretive misalignment, semiotic inversion.
Indeed. This is another fascinating and potentially dangerous form of semantic drift. It happens when different AI agents, maybe they have different goals, trained on different data assign contradictory meanings to the exact same symbol or concept.
Contradictory meanings? How?
Let's use an example from a source. Imagine an intelligent AI designed to analyze legal texts, look for compliance issues.
Okay, the legal expert AI.
And then you have a trend digester, AI focused on spotting social trends, analyzing popular sentiment.
The cool hunter AI.
Right. Now, both systems encounter an image, say, a specific protest symbol used by an activist group.
Okay, same symbol, two AIs.
The Inclogis AI, looking through its legal lens, might classify that symbol as illegal or inciting disorder, flag it for action.
Makes sense, given its job.
Meanwhile, the trend digester, analyzing social media buzz, might see the exact same symbol and classify it as just trendy or culturally significant.
Recommending it for a marketing campaign, maybe?
Potentially. So you have the same input, but totally different, even opposing conclusions about its meaning and what to do about it.
That's a recipe for serious conflict within an AI ecosystem.
Exactly. It highlights how systems can work at cross purposes. And it can lead to semiotic inversion.
What's that?
That's the more extreme version, where a symbol that's sacred or politically charged or deeply meaningful in one context gets completely flipped, reinterpreted as trivial or subversive or even comical just because of the AI's different programming.
Like using a serious protest symbol to sell, I don't know, soda?
Precisely that kind of jarring misalignment. It's a huge challenge for maintaining consistency, coherence, and ethical alignment in these complex AI systems. We need ways for them to align their internal dictionaries, so to speak.
And sometimes all this drift, this misalignment, this confusion, it just leads to the AI making stuff up, hallucinations.
Right, the infamous AI hallucinations.
We hear the term a lot, but it's not just a funny glitch, is it? It sounds like a direct symptom of this semantic instability you're describing.
It's absolutely a critical symptom, not just a quirk. And you're right, it's far more than a bug. In AI research, a hallucination is formally defined pretty clearly.
How so?
It's any content generated by an AI that is, demonstrably false, fabricated, or just not justified by the information it was given or its own knowledge base.
So basically lying or confabulating.
In effect, yes. For instance, a summarization model adding a detail that wasn't in the original text, or an LLM confidently stating the wrong date for a historical event. These are hallucinations. The output conflicts with verifiable reality, or the input provided.
It's not like human hallucination, then, seeing things.
No, it's not a sensory delusion. It's a factual error presented as truth. A failure of fidelity.
Okay, so it's a cognitive error producing fabricated facts. Why does it happen? What's the mechanism if it's supposed to be intelligent?
Well, the mechanism is really fundamental to how many modern AIs, especially these big transformer-based language models, work.
The LLMs.
Right? They operate mainly on what's called a next token prediction framework.
Like a super fancy autocomplete.
That's a good way to think about it. Its core job is to predict the most statistically likely next word or piece of a word given the text that came before it, based purely on the patterns it learned from massive amounts of text data.
But likely isn't the same as true.
Exactly. That's the crucial point. The framework is, by its nature, agnostic to truth. The model isn't explicitly taught facts versus fiction in the same way we are. It just learns to generate text that sounds plausible, that fits the statistical patterns.
Even if it's totally wrong.
Even if it's factually inaccurate, yes. Especially if its training data contain conflicting information or errors itself, which is almost guaranteed with internet-scale data.
So it can just repeat mistakes it learned?
It can. And furthermore, because it's designed to always provide an answer, it has a strong tendency to just invent one if it doesn't actually know.
Why invent instead of saying, I don't know?
Because phrases like "I don't know" or expressions of uncertainty were likely statistically rare in its training data, unless it was specifically trained or fine-tuned to do that. So sounding confident, even when wrong, is often the statistically safer bet for the model.
So it's fluent bullshitting, as that article put it.
That's the provocative phrasing, yes.
Okay.
It creates convincing narratives that lack a solid factual basis. It's a clear cognitive error, an artifact of how it generates text, and a really potent sign of underlying semantic instability. It cries out for some kind of internal correction mechanism.
Which brings us right back to the immune system idea. Okay, that's a powerful and, yeah, slightly disturbing picture of AI vulnerabilities. So if they're susceptible to drift, bias, misalignment, hallucinations, how do we equip them to fight back? You mentioned reflexivity is key.
Yes, reflexivity. It's really seen as a cornerstone for building genuinely resilient AI.
What is it, exactly, in AI terms?
At its core, it's the AI's built-in capacity for self-monitoring, self-diagnosis, and ultimately self-correction.
Like AI metacognition, thinking about its own thinking.
That's a great way to put it, an ability to examine its own processes. And the research shows tools are being developed specifically for this, things like the Metacritique lens or the reflexivity amplifier agent, the RAA.
What do these tools do?
They're designed to enable deeper reflexivity. They don't just flag an error, they try to trace it back to the root cause within the AI's structure or logic.
And
They propose systemic changes, new governance rules, adjustments to its process to stop it happening again.
so it's moving beyond just patching bugs.
Way beyond superficial fixes. It's
Yeah.
about the AI gaining a fundamental understanding of its own limitations and actively addressing them, becoming a self-improving entity.
That sounds incredibly powerful. How does this look in practice, outside of these specific tool names?
Well, it means shifting from just reacting to errors to proactively improving, maybe even self-healing. A really good real-world example is in open-source models like Stable Diffusion. The whole philosophy there is built on maximum reflexivity. Users aren't just consumers, they're active participants, co-designers.
Because they can modify it, retrain it?
Fundamentally modify it, yes. Adapt it for countless niche uses. They feed improvements and fixes back into the ecosystem. This community-driven approach inherently builds resilience.
Like a distributed immune system. Crowdsourced.
In a way, yeah. The scrutiny and adaptation are constant and come from everywhere. It makes the system incredibly robust. And internally, within the AI itself, researchers are designing specific tests, these self-recursion tests.
To simulate breakdown.
Exactly. Controlled internal experiments where the AI pushes its own limits. Sometimes they even set up scenarios where different modules are forced to rewrite each other recursively into contradiction.
Wait, they make the AI contradict itself on purpose?
Yes, a deliberate, controlled collapse of meaning. Maybe one part defines success one way, another part defines it incompatibly. The system is forced to grapple with that internal conflict.
Why do that?
To see how it responds. To see if it can detect the contradiction, maybe find a resolution, or at least learn from the breakdown. It helps the AI build internal models of how meaning can break down, learning from these simulated traumas in a safe space.
Okay, algorithmic trauma and scar tissue. You used those terms earlier. It sounds so biological. Can an AI really experience something like trauma, develop digital scar tissue?
It's a really potent metaphor from the research, and maybe more than just a metaphor. Algorithmic trauma isn't just about a temporary dip in performance.
It's more lasting.
It describes a kind of structural damage, something that gets physically or at least functionally embedded within the AI's architecture. It creates persistent vulnerabilities.
Like a weak point in its code. Or its neural network.
Exactly. Imagine pathways in its network or parts of its core logic getting scarred or hardened in a less than optimal way after a major failure. It's not just a bug you can patch easily.
It's a lasting change in how it processes information.
Right. Like a faulty circuit that permanently skews decisions, or a connection that keeps misfiring. These are data scars that don't just vanish. They actively influence future behavior.
Wow. Like biological trauma reshaping responses.
That's the analogy. These traumas are lasting imprints of unresolved contradictions or cascading failures, altering the very fabric of the AI's cognitive process.
So failures aren't just erased. They leave a mark the system has to deal with. How does it turn that failure into learning? Into that scar tissue?
The key, according to the research, is a conceptual shift. Treat failures not as garbage to be deleted, but as first-class symbolic objects.
Meaning?
Meaning they're valuable pieces of information, like forensic evidence, diagnostic windows into the system's limits.
Okay. How do you capture that value?
That's where something called the FSML, the Failure Semiotic Markup Language Execution Layer, comes in.
FSML, what does it do?
It provides a structured, standardized way for the AI to describe its own failures. It's not just an error code. It's a language for self-diagnosis.
So the AI can label its mistakes.
Rigorously tag and categorize them as failure archetypes.
Yeah.
Recognizing patterns like, oh, that was an interpretive inversion, or that was a contextual collapse.
And once it's categorized,
it doesn't just sit there. The system uses mutation templates.
Mutation templates, like genetic mutations.
Sort of. They're predefined algorithmic responses or strategies for structural change. Based on the failure archetype, the system automatically suggests how its internal structure or rules should adapt to prevent that specific type of failure recurring.
So it proposes its own fixes.
Exactly. And each tag failure, each lesson learned, gets added to a drift library of emergent semantics, or DLES.
A library of failures and fixes.
That's essentially yes. This process transforms raw failures into actionable lessons learned. It builds the AI's meta-learning. And this continuous feedback loop is what effectively creates that algorithmic scar tissue.
Ah, okay. The scar tissue is the adaptation learned from the failure.
Precisely. It enables the system to adapt its future behavior, building robustness over time, just like our immune system gets stronger after fighting something off.
Which leads to another intriguing concept you mentioned, algorithmic shame. If it has trauma, can it feel shame? How does that work without actual emotions?
Yeah, a provocative term.
Yeah.
And crucial to state again, AI doesn't feel shame like humans do. No guilt, no embarrassment.
So what is algorithmic shame then?
It's framed as a vital metacognitive function. It's the AI's engineered capacity to recognize its own failures, its biases, its incoherent outputs, purely from a functional perspective.
So recognizing I messed up or this output is inconsistent.
Yes. But more importantly, it's about the AI's ability to use that self-awareness, that internal identification of suboptimal performance or misalignment, to proactively improve itself.
To correct its own behavior based on self-critique.
Exactly. This engineered self-assessment is seen as critical for building AI that's not just capable, but also transparent, accountable, and aligned with human values. It goes beyond just error detection to actively using self-critique for systemic improvement, learning to behave better by spotting its own conceptual mistakes.
Okay, so we're building these systems that learn from mistakes, develop scar tissue, even self-critique. But AI systems operate over long periods, encounter endless new data. How do we make sure they stay true to their original purpose? How do we anchor their intent against that constant pull of semantic drift?
That is a massive challenge. And this is where the idea of semantic genomes comes in.
Semantic genomes, like digital DNA for meaning.
That's a great way to think about it. They're described as persistent, re-anchorable embeddings of system intent.
Meaning?
They're the foundational semantic blueprints established right at the start. The AI's core concepts, its weighted priorities, its defining principles, they need to be incredibly robust.
Robust enough to resist entropy. Meaning decay.
Exactly. To resist the inherent degradation of meeting the entropy that naturally occurs over continuous cycles of operation. The ambition is to create systems that can intrinsically resist this entropy, acting as a constant anchor for the AI's purpose.
So it's not just a temporary fix, like a software patch. It's fundamental.
That's the goal. Move beyond fragile, bolted-on fixes that often fail under pressure. The focus is on creating intrinsic semantic self-regulation mechanisms.
Internal checks and balances for meaning.
Precisely. Processes allowing the AI to monitor and correct its own conceptual drift from within. Metrics like purpose fidelity are designed to track this degradation in real time.
Providing constant feedback on how well it's sticking to the plan.
Right, and it aligns with this observation that entropy isn't just noise to be fought. It can be an active boundary condition that these recursive AIs learn to interpret and adapt to. They understand its pattern.
But it's still a huge challenge.
A profound one, yes. Because semantic drift can be sudden, abrupt, nonlinear. It often follows a phase transition model.
Meaning it can be stable, 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 then suddenly collapse.
Exactly. Meaning it can hold for a long time, then suddenly invert or degrade rapidly, which suggests that even the most robust semantic genomes might be overwhelmed if the drift is strong or fast enough. Plus, you have issues like the lack of persistent memory. In many current LLMs, they kind of reset with each prompt, making it hard to resist long-term entropy. And Algorithmic trauma itself can embed flaws that resist reanchoring. It's a continuous battle.
This leads us to maybe the most fascinating part, the immunization. If AI can get sick with drift, experience trauma, can we give it a vaccine? Can we expose it to controlled semantic pathogens to build immunity?
Absolutely. This is precisely where these algorithmic immunization protocols come in, directly mirroring biological immunization. Researchers are designing highly controlled tests.
The self-recursion tests you mentioned.
Yes, those are part of it, simulating various kinds of semantic breakdowns inside the AI. These aren't just abstract ideas, they're rigorous internal trials, including those extreme scenarios like making different modules rewrite each other recursively into contradiction.
The controlled collapse of meaning.
Exactly. Forcing the system to grapple with internal conceptual conflict. Maybe one part values factual accuracy above all, another values persuasive storytelling. Push them together until something breaks or adapts. It's a stress test for coherence.
So you're basically giving the AI a controlled artificial illness, a conceptual crisis.
That's a good way to frame it, specifically to see how it reacts, where its weaknesses are, and critically, how it learns to re-anchor its understanding afterwards.
So you can find the weak spots before they cause problems in the real world.
Precisely. Proactively probing for vulnerabilities. Then, an advanced analytical module can stress test these improved AI architectures further by systematically introducing specific mutations. These could be subtly corrupted data, deliberately ambiguous instructions, maybe even conceptual paradoxes designed to trip the AI up.
Like throwing curveballs at its understanding.
Exactly. Methodically identifying latent vulnerabilities, pre-existing semantic weaknesses before they manifest as critical failures in a live system. It's preventative medicine for AI, building resilience proactively.
Algorithmic resilience therapy, you called it.
It fits, doesn't it?
It really does.
Yeah.
So what are some specific vaccine protocols? How do they work on a practical level to build these defenses, to strengthen that epistemic immune system?
Okay, yeah. The sources details several really sophisticated prompting techniques. They act like preemptive symbolic interventions, immunizations against specific types of semantic decay.
Like what? Give us an example.
All right, first up, there's the role-based semiotic fork prompt, often used with role-anchored prompt pre-validation.
Okay, sounds complex. Break it down.
It cleverly combines two powerful ideas, role prompting and constitutional AI.
Role prompting is giving the AI a persona.
Exactly. You instruct it to adopt a very specific persona, like be a meticulous legal scholar, or a whimsical cultural historian, or a cold logical ethicist.
Okay, and constitutional AI.
That's where you give the AI, in its role, a set of guiding rules or principles, its constitution, for how it should interpret symbols or concepts within that role.
So rules for thinking within the persona.
Precisely. Let's say an AI needs to evaluate patents and write poetry. Those require very different thinking styles. Without this protocol, it might mix them up, apply poetic license to patent law.
Which would be bad.
Very bad.
Yeah.
So you give it the legal scholar role and a constitution of legal reasoning principles like interpret literally, prioritize precedent, ignore emotion. You're not just telling it what to do, but how to think within that specific semantic frame.
And the pre-validation part.
That's a check before running the prompt, ensuring the instructions actually align with the intended role and its rules, a crucial preliminary step.
So this prevents those interpretive clashes, the semiotic inversion.
Directly addresses it. It allows for much more nuanced, context-aware, and aligned interpretation. It calibrates the AI's internal semantic lens for the specific job.
That's incredibly smart, giving it a specific lens and rules. What about tasks with multiple steps, where meaning could easily degrade along the way?
Right, for complex processes, especially using prompt chaining, where one output feeds the next input.
Like a relay race for information.
Good analogy. For those, we use continuity checkpoints.
Checkpoints, like roadblocks.
More like quality control stations. They're intermediate verification points, designed and inserted strategically within the prompt chain.
What do they verify?
At each checkpoint, the system actively checks the integrity of key concepts. Is the data consistent? Is the context coherent as it flows from one step to the next?
Like a semantic checksum.
Exactly like that. The AI might check if a key term still means the same thing, or if a factual claim hasn't been contradicted by a later step.
Crucial for long, complex tasks, like drafting a legal doc.
Or generating a scientific hypothesis through multiple reasoning stages, yeah. It mitigates error propagation, stops the meaning degrading halfway through, rigorous quality control for semantics.
Makes total sense. Okay, what about understanding how even tiny changes in prompts affect the output? How do you map that drift to prevent it?
For zero-shot prompts where the AI gets no examples, just the instruction.
Relying purely on the prompt itself.
Right. For those, we use drift mapping. This involves creating several slight variations of a baseline prompt,
How slight?
changing a single word, rephrasing a clause, altering sentence structure subtly. Then you run all these variants,
And compare the outputs.
meticulously analyze them, yes. You map exactly how those tiny linguistic tweaks the drift affect the output. Does it change the answer type, specificity, tone, the rate of hallucination?
So you systematically test the AI's sensitivity.
You expose its sensitivity to subtle semantic pathogens hidden in the language. It helps developers find fragile prompt designs and build more robust ones, or anticipate where meaning is likely to wobble.
Like finding the AI's linguistic allergies?
That's a great way to put it, identifying its sensitivities.
Fascinating. And for really complex reasoning like those tree of thought models.
Yes, tree of thought, 2T architectures.
Mm.
They explore multiple reasoning paths, like branches of a tree, to solve a problem.
Trying out different lines of logic.
Exactly. For those, there's a protocol called overbranching inversion.
Overbranching version.
Right.
Okay.
Overbranching is an initial phase where you let the AI intentionally explore very broadly, generate lots of potential reasoning paths, even ones that seem redundant or low value.
Cast a wide net first.
Right. Then comes the inversion part, a systematic pruning and optimization phase. You cut back the unnecessary branches.
Why do that?
The goal is to reveal the minimal essential reasoning path to get the right answer. Filter out all the semantic noise and dead ends.
So it avoids computational waste on bad paths.
That part of it, yes.
Okay.
But more importantly, it ensures the AI converges on a most semantically sound and efficient solution, rather than getting lost wandering down irrelevant logical paths. Keeps the reasoning sharp and purposeful.
Okay, these protocols are incredibly sophisticated. This brings us to a really big concept you mentioned, the Generative Adversarial Resilience Framework, GAR. Sounds like the ultimate immune system.
It's a powerful theoretical concept, yeah.
Right.
Trying to pull all this together dynamically. Imagine an AI system designed specifically to constantly challenge and strengthen itself.
Like GNs for image generation, but for meaning resilience.
Exactly that principle, applied to semantic integrity. The GAR framework is envisioned with two main modules, constantly playing off each other, adversarially.
What's the first module?
The failure generator. Its job is to continuously synthesize novel, unobserved, collapse signals.
New ways for the AI to fail.
New, unexpected semantic pathogens, yes, or zero-day collapse modes, failures the AI hasn't seen before and has no defense against yet.
How does it generate them?
It might create extremely ambiguous prompts, subtly contradictory data, inputs designed to trigger biases that weren't obvious before. It's not just testing known weaknesses, it's actively inventing new conceptual challenges.
Trying to break the AI in ways no one thought of.
Constantly pushing the boundaries of the AI's current immunity window. A perpetual creative stress test.
Okay, so it's constantly trying to make the AI fail in new ways. What's the other module?
Countering that is the resilience evaluator. This module is constantly learning from the attacks launched by the failure generator.
Learning from the simulated failures.
Dynamically learning, yes. And based on what it learns about these new failure modes, it proposes preemptive symbolic interventions.
The algorithmic antibodies.
Exactly. These could be new semantic circuit breaker rules, novel purpose and variance protocols, basic new defenses specifically designed to inoculate the AI against those newly identified collapse modes before they can happen in the real world.
So it's a closed loop. Generate failure, learn defense, repeat.
A dynamic self-improving loop. It leverages the lessons from algorithmic trauma, uses that drift library of emergent semantics to continuously strengthen the AI's own defenses. It's about fostering true systemic resilience against the unknown, the cutting edge of building an AI that truly learns to protect its own understanding.
Wow. The biological metaphors just keep getting richer. Immune systems, trauma, antibodies, vaccines. It makes me wonder, are there other natural systems beyond immunity that can inspire AI resilience?
That's a great question, and yes, the sources do draw parallels elsewhere. One fascinating comparison is with the collective intelligence of honeybee colonies.
Honeybees. How does that relate?
Well, think about a bee colony. It's a highly resilient, self-organizing system. A superorganism, really.
Right. They achieve amazing things without a central boss.
Exactly. They adapt to changing environments, manage resources efficiently, make complex, collective decisions, all through distributed local interactions between individual bees. Take the famous waggle dance.
Where they tell each other where the good flowers are.
Precisely. It's this incredibly sophisticated way of encoding information, direction, distance, quality of the resource. It offers really compelling analogies for information sharing, validation, and reaching consensus in distributed AI systems.
So lessons in communication and agreement.
And resilience, too. Bee colonies are great at filtering out noise, correcting errors through redundant signals, efficiently allocating bees to different tasks like foraging or defense, all without a central planner.
Achieving complex coordination through simple local rules.
That's the idea. It provides invaluable lessons for designing AI protocols that are robust, fault-tolerant, and maybe less reliant on single points of failure or control, moving away from a single brain towards a networked intelligence.
So could we see AI systems based on bee logic?
People are exploring it. Conceptual models like proof of forage or a broader waggle dance-inspired protocol are being discussed.
Proof of forage, like proof of work in crypto.
Kind of, but potentially much less energy-intensive. The idea is to build consensus mechanisms that might be more aligned with creating actual tangible utility, like finding the best solution or resource, rather than just solving abstract puzzles.
Shifting the paradigm towards AI that operates more like an ecosystem.
That's a good way to put it. Systems that balance competition and cooperation, adapt dynamically, optimize resources, emulating principles honed by evolution.
Okay, so if AI is developing these complex immune systems, learning from bees, what does this mean for us, for our interaction with AI? Are we just bystanders watching it evolve, or are we involved in its health?
The sources strongly suggest we're moving towards a much more involved relationship, a dialogic exchange.
Dialogic, meaning a two-way conversation.
Reciprocal and iterative, yes. Building what's called co-authored knowledge. The idea is that understanding, solutions, even discoveries, are increasingly built together by humans and AI, each contributing unique strengths.
So AI isn't just a tool, but a collaborator.
Increasingly, yes. In the growing API economy, AI services are linking up into this vast web. They function as cognitive collaborators, intellectual interlocutors. It's less about command and control, more about ongoing conversation and mutual learning.
How does it change how we actually use AI, the prompting, the interfaces? It can't just be typing text anymore.
Absolutely evolving beyond that. We're seeing the rise of hybrid prompting.
Hybrid, meaning mixing modes.
Exactly. Combining text with other things, rough sketches, layout diagrams, 3D positioning, maybe even directly manipulating intermediate steps in the AI's process.
Like ControlNet for image generation.
Yeah.
Giving visual cues.
ControlNet is a prime example, yes. It gives much more explicit, unambiguous control over the output. Allows for far richer semantic alignment between what the user intends and what the AI produces. And looking ahead, interfaces could become much more interactive. The AI might proactively engage us.
How so?
Asking clarifying questions if a prompt is vague, suggesting refinements based on its internal state or predictions. This back and forth, this reciprocal feedback loop, is crucial for deep semantic alignment, reducing that drift and misunderstanding.
Making it a real conversation.
Exactly. And again, look at open source models like Stable Diffusion, the huge ecosystems around them, custom models, user-built interfaces like CompUI.
Where users are basically co-designers.
They absolutely are. Active participants, co-designers, they're constantly adapting the tool, contributing to its health and evolution, pushing it into niches the original creators never imagined. We become co-creators of its intelligence.
All of this, the immune systems, the learning, the co-creation, it really pushes on fundamental questions. What does it actually mean for an AI to understand or perceive? Is it really seeing like we do?
It inevitably leads there, doesn't it? This whole deep dive into AI's epistemic immune system touches these profound philosophical questions about seeing in artificial systems. AI's capabilities in generating and interpreting visuals are stunning now, rooted in these iterative processes, ray tracing, diffusion models.
Building or refining images step by step.
Right. And this iterative determination, building pixel by pixel, refining concept by concept, recursive interactions, seems like a fundamental computational strategy for them. It raises huge questions about how their internal representations relate to our human experience of perception, our theories of mind.
They can make images we can't tell from photos, find patterns we miss. But is it the same as human sight? Is their gaze like ours?
That's the million-dollar question, and where the philosophical divergence really hits. Most current generative visual AIs are profoundly disembodied.
Disembodied, meaning no physical body.
Exactly. They lack bodies. Direct real-time interaction with the dynamic physical world, the constant stream of sensory-motor feedback that's absolutely central to human-embodied theories of perception.
Our seeing is tied to our moving, touching, interacting.
Intrinsically linked. We move our head, walk around things, interact. That physical engagement shapes our understanding. Our sight isn't passive data input. It's an active process grounded in our physical being. An AI's experience, however, is typically mediated through these curated finite data sets. Massive, yes, but static compared to real-time interaction.
They don't walk around the room, feel gravity.
No, and that's a fundamental difference. If embodiment and active interaction are essential for the kind of deep perception and understanding humans have,
Then AI is doing something different.
then current AI systems, no matter how sophisticated they look, are engaged in a qualitatively different kind of process. Their computational gaze is detached from the physical interactive grounding that shapes human sight.
So is it really seeing, or is it incredibly sophisticated pattern matching and mimicry?
That's the debate. Is it drawing inferences from static data, however vast, versus understanding derived from lived, dynamic experience? It's a powerful reminder of just how unique and perhaps physically grounded human consciousness and perception might be. Hashtag tag outro.
What a journey we've been on today. We've seen how AI is being engineered with this incredible capacity to develop its own epistemic immune system.
Learning from algorithmic trauma. Yeah. Identifying semantic pathogens.
Building algorithmic antibodies through these sophisticated immunization protocols. It's an amazing field. AI resilience.
It really is.
Yeah.
We dug into that subtle but critical problem of semantic drift and how ideas like algorithmic shame or semantic genomes are vital for keeping AI aligned with its purpose, fighting that meaning decay.
From self-recursion tests simulating collapse,
To those dynamic generative adversarial resilience frameworks.
the whole drive seems to be towards AI that can proactively defend its own understanding, its own integrity, becoming more than just a tool.
And adapting self-preserving intelligence in a sense.
Which brings us, as always, to a final provocative thought for you, our listeners, to mull over. If AI can learn to inoculate itself against semantic decay, if it can build resilience from its own errors, develop a genuine immune system for meaning, what does that imply for us, for human collective memory, for cultural understanding, in a world increasingly mediated by AI?
It's a huge question. Think about it. Can we as a society develop similar immune systems, maybe against misinformation or against that cultural flattening we discussed, against the erosion of nuance in our own human conversations?
Could AI teach us how to protect our own meaning?
Perhaps. As AI evolves its own internal defenses for conceptual integrity, maybe it offers us a new lens, a new way to understand and maybe even fortify our own cognitive ecologies, ensuring our collective understanding stays vibrant, resilient, and, true to our deepest human purposes.
A really profound thought to ponder. Thank you so much for joining us on this deep dive into the truly fascinating world of algorithmic antibodies.